lower and upper sums of the function sin x on the closed interval 0 pi by dividing it into 6 equal parts. So here we are having a to be equal to 0 and b to be equal to pi, right? And if we are dividing this into 6 equal parts, then length of each part will be b minus a divided by the number of parts, right? That is pi minus 0 divided by 6, which is pi by 6. So on this we are working. So let's take the function to be sin x on this given interval, and length of each part is equal to b minus a divided by n, that is equal to pi minus 0 divided by 6, which is pi by 6. And now finding the points of subdivisions. So x0 is your a, that is 0, and x1 is pi by 6, x2 is 2 pi by 6, x3 is 3 pi by 6, x4 is 4 pi by 6, x5 is 5 pi by 6, and x6 is 6 pi by 6. We can also write x2 as pi by 3 and x3 as pi by 2, just cancel them, and x4 can be written as 2 pi by 3 and x6 can be written as pi, right? And now writing the subintervals, that is from 0 to pi by 6, and then from pi by 6 to pi by 3, and then pi by 3 to pi by 2, and then pi by 2 to 2 pi by 3, and then 2 pi by 3 to 5 pi by 6, and finally 5 pi by 6 to pi. Very fine. So these are the 6 subintervals. And now calculating all the greatest lower bounds and least upper bounds from these subintervals. So the greatest lower bounds, that is small m1, m2, m3, m4 up to m6. So finding m1, so that is sin of, just take the value of x equal to 0 for this, that is 0, and then sin of, for the second subinterval we are taking the value pi by 6, and sin pi by 6 is 1/2, and then taking pi by 3, so sin of pi by 3, that is equal to root 3 divided by 2. Now for the fourth subinterval, sin of pi by 2 is 1 and sin of 2 pi by 3 is square root 3 by 2. Which is the smaller one? Square root 3 by 2? Yes. So for this subinterval, we take the values of x to be 2 pi by 3, 5 pi by 6 and pi to find the greatest lower bound. So m4 is sin 2 pi by 3, that is square root 3 by 2, and m5 is sin of 5 pi by 6, that is equal to 1/2, and m6 is equal to sin of pi, that is equal to 0. Now calculating all the upper least bounds. For that we take this value of x, for capital M1, for capital M2 this, for capital M3 this. So capital M1 becomes sin of pi by 6, that is 1/2, and then we need to take this value pi by 3, that is equal to square root 3 divided by 2, and capital M3 is sin of pi by 2, that is equal to 1. And now for the fourth subinterval, because sin of pi by 2 is 1 and sin of 2 pi by 3 is square root 3 divided by 2, so which is the greater value? This one, right? So we need to take sin of pi by 2 for capital M4. So sin of pi by 2 equal to 1, and for capital M5 we have to take sin of 2 pi by 3 and then sin of 5 pi by 6. Sin of 2 pi by 3 is equal to square root 3 divided by 2, and sin of 5 pi by 6 is equal to 1/2. You can also match these values with each other. So greatest lower bounds are smaller than the upper least bounds. Right? Okay. Let's find out the lower Riemann sum now. So this is equal to summation I going from 1 to n, where n is the number of subintervals, that is equal to 6. Right? Small mi delta I, where delta I is xi minus 1. That is the length of each sub-interval, which is equal to pi by 6, right? So this is equal to summation I going from 1 to 6 small mi into pi by 6. So now finding this, so this is equal to, I take pi by 6 outside and writing here m1 plus m2 plus m3 up to m6, right? So let's put all the values of mi's. So this is equal to pi by 6. Okay, what is m1? It is 0 plus m2 is 1/2 plus m3 is square root 3 by 2 plus m4 is square root 3 by 2 plus m5 is 1/2 plus m6 is 0. So this is pi divided by 6. Half and half is 1 plus these two are 2 root 3 by 2. That is square root 3. So this is equal to pi by 6 square root 3 plus 1. So this is your lower Riemann sum. Now calculating the upper Riemann sum. That is equal to summation I going from 1 to 6 capital Mi delta I, where delta I is length of each sub-interval, which is pi by 6. So that is equal to summation I going from 1 to 6 capital Mi into pi by 6, right? So let's take this pi by 6 outside. So this is pi by 6 into sum of all these capital Mi's. So that is pi by 6. Okay, capital M1 is 1/2, then is square root 3 by 2, then is 1 plus square root 3 by 2 plus 1/2. So this is pi by 6. Okay, this becomes 1 and then these two is 2. So 2 plus 1 is 3 plus sum of these two is twice of square root 3 divided by 2. This cancelled out with each other. And this is pi by 6 into 3 plus square root 3. So this is your upper Riemann sum. So hence, lower Riemann sum is equal to pi by 6 into square root 3 plus 1. And upper Riemann sum is equal to pi by 6 into square root 3 plus 3. Okay, thank you.